Go ahead and try this question. If f of 3x plus 1 equals 6x plus 4, then what does f of x equal? This is a question where, again, just like previous videos on functions, whether for the SAT or the ACT or the subject tests, the first thing is to know the difference between the input and the output. But the second thing in this case is not to be confused by the fact that these look very similar, right? Normally you're used to seeing f of x, right? Not f of 3x plus 1. And you might think that there can be some direct connection where I can, for example, add 3x plus 3 to this to get 6x plus 4. So you might be tempted to go with something like choice C, or maybe you think that this is equal to f of x, so you pick f of x equals 3x plus 1 because that's what's in here, like x equals 3x plus 1. Or maybe you think that since this equals 6x plus 4, then f of x would equal 6x plus 4. These are all traps because these are all cases of not fully understanding the difference between the input and the output and how you deal with an f of x and an f of 3x plus 1. So we're going to get rid of A, C, and D because those aren't our answers. So let's figure out what's going on here. So we're told that f of 3x plus 1 equals this, and we want to know what f of x is. Now remember how this works. Let's say we've got f of x is, let's pretend f of x is equal to 3x plus 1. What happens if I then ask for f of 3x plus 1? Remember what we've said in previous videos about functions, symbolic functions. It's really just pattern matching. Since I've replaced x with 3x plus 1, I'm going to replace x with 3x plus 1 in the equation, in the function. So in this case, I would get 3 times 3x plus 1 plus 1. This would be 9x plus 3 plus 1, so 9x plus 4. Now, if we look at what it should equal 6x plus 4. We see that these are not the same. 6x plus 4 and 9x plus 4, they're somewhat close, but they're not the same. So this can't be our answer. 3x plus 1, again, we'll kind of put another cross through it, can't be our answer because when we replace x with 3x plus 1 in the function as defined by 3x plus 1, we don't get what we would have expected. We don't get 6x plus 4. So the key, what we're going to do here, testing our functions, we're going to take each of these choices. We're going to pretend, as we did in this first case, that f of x equals this function, that it is the answer. We're going to plug 3x plus 1 in for the x because we're making that substitution. And what we hope to get is 6x plus 4. So let's try choice B. So here we're going to define f of x as 2x plus 2. Now we're going to say, all right, now we want f of 3x plus 1, and we're hoping that it's going to equal 6x plus 4. So now again, we've replaced the x with 3x plus 1. We replace the x with 3x plus 1 in the equation. So this is going to be 2 times 3x plus 1 plus 2. This is the same thing as 6x plus 2 plus 2. Which, lo and behold, is 6x plus 4, which again is what we wanted. So the answer here is going to be choice B. And if you want, just for your own education, you can test out C, D, and E, and you'll see that they're not going to give us the 6x plus 4. So again, remember the difference between the input and the output. When you input this into f of x, whatever f of x is defined as, then you're going to get some output, and you want to make sure that output matches. There's a way to do it more directly, which is a bit confusing. Basically, you take this and you try to find multiples or units of 3x plus 1, and then you can use that as your function. It's a bit confusing, so I'm not going to show it. I think this is the better way to do it because it really it reinforces the main ideas we've talked about previously with functions, inputs and outputs. To learn more about Reason Prep's SAT, SAT subject test, and ACT video courses, go to reasonprep.com/enroll, and you can find the link in the description below the video.